All right, let's get started. My talk is called How to Put a Penguin in the Cloud, and it's all about putting Linux on Azure. My name is Brendan Richards. I'm a solution architect at SSW, and that means I spend most of my time at client sites doing work for those clients. Every now and then I get out to do user group talks and occasionally conference talks, and I also take part in SSW training. Microsoft has not always had a great relationship with Linux. I should probably move on one day and stop using this slide, but I've got a long memory. And so this is then head of Microsoft, Steve Ballmer, and the statement he made is Linux is a cancer. A few years later, the message turned to this. Quite different. This is the Satya Nadella years. And when this happened, they started making loads of awesome software. So all this stuff works on Linux, made by Microsoft. And because of that, we now can have nice things. There's all this second universe of software out there that we can now use with our Microsoft software, and it plays together nicely, and you've got so many more options of things to do. So let's take a look at the table of contents we're going to cover. In the full package, I'm going to talk a little bit about Unix architecture, how the system hangs together, and how everything's built out of packages. Then the second section, if there's shell below, I'm going to cover a few features. I'm not going to cover how to use the Linux command line. There's a whole bunch of other talks on that, but I'm going to teach you the few essential things you need to know to get stuff working with Linux. Then I'll cover managed VMs with the Azure CLI. I'm going to look at the Azure Linux web app, then the Azure web apps for containers, and finally I'm going to touch on Linux functions and Azure Sphere. So let's get started with the full package. This picture is how we generally describe all Unix architecture. And I've picked Unix rather than Linux here because it's common to all the flavors of Unix, from classic Unix from the 1970s through to Mac OS X through to Linux. And when you talk about Linux, what Linux actually is a thing called the kernel. The thing in the middle is called the kernel, and that is what talks to the hardware. It talks to the hardware and manages running processes. The rest of the system interacts with the kernel via system calls, and the name of that API for system calls is called POSIX. And the commonality of POSIX means that software you write to run on Mac OS X with a little bit of tweaking can be made to run on Linux as well. Then around the outside you've got the shell, which is your kind of low-level command line for interacting, and then you've got libraries and applications on the outside. So Linux is just that bit in the middle. So when you talk about a Linux operating system, it's really a Linux-based operating system. Linux is the bit in the middle that manages the kernel. Everything else is different. Everything else are other packages. So Linux was created by Linus Torvalds in the early 90s. You might have heard of him. He was also the man behind Git. So Git exists because Linus needed a better way of managing branches in order to make updates to the Linux kernel. So what was different about Linux? Well, when Linux came along, there were other kernels around, and there was plenty of software to run in a Unix system. But the difference with Linux is it ran on the commodity x386 hardware, which means you can suddenly scale out lots of very cheap servers. Well, when Linux was created, it wasn't created in a vacuum. There was this other free software kicking around that had been built for Unix that they could just compile in. That was a GNU project. So this has things like a GCC compiler, which is what you use to build software. So without a compiler, you can't build anything. And loads of shell tools, libraries, and applications. So all this whole chain, basically it's the GNU project that actually makes it an operating system on top of the Linux kernel. And then finally, at the very top, you've got the teeming hordes of the open source community, making all kinds of bits of software for all kinds of different reasons that all get pushed in to make a huge system. But managing all these pieces of software is hard. If you had to go and individually download each of these project source files, compile it yourself and put it into a system, it would take you forever. So that is where distributions come in. Distributions are projects that take all these open source applications, compile them up, turn them into packages, and then turn it into a whole system. So Debian, Linux, Red Hat, they're all names you've heard of. What they're doing is taking this open source software and making it a cohesive system. And the way they do that is each of them have package managers, and they have all slightly different package managers. So Debian and Ubuntu have something called apt. Red Hat has RPMs and yum. So with package management, it's like NuGet or NPM, but for the whole computer. So if say you're doing NuGet and you download a package, and it depends on another package, it will download that too and put it in your system. But with package management on Linux, it's the entire computer, the kernel, the operating system, how it boots. Every single thing about the software comes down to this package system, which means everything is a package. And these package repositories, so these online archives of all the packages available to your system, also manage the dependencies. So you download one thing, if it needs a dependency, you'll also download that. Different distributions have different package managers, and distros have different release cycles. So let's introduce the concept of a release cycle. So this is the Debian release cycle. I'm using this one because it's one of the kind of slowest and most well understood. And what they do at Debian is they always have 3 current versions. One called stable, one called testing, and one called unstable. And what happens is, as new versions of the software are released, they get compiled into packages, pushed straight into stable. That's happening all the time. So you could go and grab that version, say, I'm going to install Debian unstable, and they can work. You get operating system. What the Debian teams say is, if it breaks, you get to keep both pieces. So over time, packages move from unstable to testing. And over more time, it eventually comes to stable. And the key thing about this is it's a huge amount of time. Like, it's basically 2 years before it gets from, in some cases, from unstable to testing. Something about code names. All the code names of Debian are named after characters from Toy Story. So the current stable is Buster, the current testing is Bullseye. At some point in the future, a new name will be given to testing, and Bullseye becomes stable. Unstable is always called Sid, because in Toy Story, Sid was named the naughty kid next door that breaks all the toys. So what if you don't want to wait for new software to come through that release cycle? Like Veruca Salt, that's not quick enough for me. That release cycle is longer than the lifetime of some JavaScript packages. So what can you do? You've got a few ways of getting software. So the first place you can go is the official repository, the repository that comes with your operating system, with your distribution. But it takes time for software to make it into the stable branch of that repository. So your second one is called a personal package archive, or a PPA. That's where a software provider will add an extra repository to add to your system, and you can start getting newer packages from there. If you're using a dev tool such as C# or Node, sometimes they have their own package managers. So you install the latest version of that package manager, you can download software that way. Another way of getting software, some providers, like Oracle with their VMware, will give you a binary installer for their package. That's the default way of getting software in Windows. It's kind of option number 4 when you're talking Linux. And finally, the nuclear option, if you really want to have a piece of software and there's no package for it made for you, you can download the source code, build it, and make it yourself. But I've not had to do that for a very long time. The thing I want you to remember is PPA, Personal Package Archive, because that's incredibly useful for getting software into your system. And if you can remember PPA, you're going to find stuff on Google. So let's cover if there's shell below. So what we're going to do is cover a few key commands that get you working with Linux. I'm going to cover some important locations where to find stuff. I'm going to cover remote access with SSH. I'm going to cover installing stuff with apt, and then I'm going to cover using a PPA to install non-standard stuff. So some important locations, /home/Brendan, that's my home folder. So every user will have their own home folder. It's where you can put your stuff. In Linux and in Unix, a folder that starts with a dot is called a hidden folder. It doesn't restrict your access to it, you just don't see it by default. And inside your home folder, you'll see a whole group of hidden folders starting with the dot, and that's user-specific config for that program. So .ssh is my configuration inside my home folder. /etc, or etc, as some people say it, is for global configuration. So if you install a web server, and the configuration for that web server will probably be in /etc. And all configuration in a Unix system is done by text files. /var is for runtime files, variables. So for example, log files. If you've got a web server generating logs, that'll go into /var. If you've got a database and there's database files, that'll go in /var. And finally, 2 more important things. The thing to note about a Unix system is there's no separation from the kind of file path system and the rest of the system. So in Windows, you've got drives to mount, and then somewhere else where your printers are, device manager. There's none of that in Linux or on Unix. Every single thing has a location somewhere under / on that path. So /dev is where all your devices are found. If you know the right bits to send to the right path, you can directly manipulate your hardware. And finally, /proc is where all the running processes store their information. It's a virtual file system that tells you about which processes are running. So the next thing I'm going to show you is a program called SSH. Stands for Secure Shell. And this is the thing you can use to log in to an external server. So I'm going to type SSH, my username, and then a URL, brendanxserver.cloudapp.net. And it will ask me for a password. I type in the password, and bang, I'm now inside that server. So what's going on here is a bit of shell program inception. I have this program on the outside that's called the terminal, and that catches characters I type and displays them on the screen. The characters I type when I hit enter get sent to a program called the shell program, that interprets that command and then goes and runs programs and does stuff. So what's happening right now is when I type a command in, Secure Shell is taking that command, streaming it over a secure encrypted connection to the remote server. There's a shell program running on the remote server, and that's what's interpreting my commands and then sending the text back. So I can log in with a password, but what if I want to automate a script and kind of work with that machine without putting my password each time? I want a kind of running process I can schedule up. So how can we authenticate against the machine without providing a password every single time? What I can do is I can generate two keys, a public and private key with SSH. So it's SSH keygen, just TRSA. It'll ask me for some details, and then it will generate two files, one private key and one public key. With public-private key encryption, the way it works is you publish your public key out to anyone. They use your public key to encrypt stuff for you, but only you can decrypt it because you've got the private key. So what you do is, this example is I'm using SCP, which is secure copy. I can use that to copy that public key up to that remote server. Then I'll log into that remote server and add that key onto the end of a special file, .ssh/authorized keys. As soon as I've done that, I can SSH into my server, and bang, I'm in there without putting in a password. So this type of SSH key exchange is used quite a lot if you're working with Linux. So for example, if you go to Microsoft Azure and you want to set up a brand new virtual machine, you've got an option here to specify the SSH public key. Then into the box below, you paste in the contents of that file you just generated, and bang, you can log into your remote server without providing a password. If you want to work with Azure DevOps and Git from Linux, I'm going to use SSH as your method to get in the files. You can click Manage SSH Keys, send up your key, and then you can authenticate automatically against Azure DevOps. And the same concept is what's behind Octopus Deploy. So for my mind, Windows had a terrible way of getting code deployed. Copying files between two systems was terrible until Octopus Deploy came along, put a service on that machine, and then set up proper keys in order to authenticate across. And that's what that Octopus thumbprint is all about. The next thing I'm going to talk about is how other applications in Linux world use SSH. There's a concept in Unix world that is write program to do one thing and do it well. So SSH is that program that does secure transfer of stuff well. When Git came along, they didn't then go, oh, we need to write our own network stack on top. They tunnel their work through SSH. And to give you an example, I'm going to show you what we had to do one day when we lost access to a Git repository online. So I'm going to show you this via Jason Taylor's Northwind Traders Git repository. I'll be using this a lot more later as well. But in this case, I'm just using it to do some SSH work. So JK and I were working away for a client. We were logged into their Azure DevOps, and they made a change to their Active Directory, and suddenly we were locked out. We'd been using Git, so we had a full copy of the code locally, but we couldn't push new changes. And me and JK needed to work together for a few days while they fixed that up. So what we did is pretty much this. We already had it cloned, so I'm going to clone down from Jason Taylor from GitHub. So now I've got a full local copy of that source file. Then I'm going to SSH into a remote server, can be any remote server that I've got access to. And then on that remote server, I make a folder to store this repository. Inside that folder, I type git init -- bear. That creates a new empty repository on that remote server. I exit and come back to my local copy of the code, and then I run this command, git remote add, give it a new remote name, and then a path for that system. And the path I'm using is an SSH URL, user@server.net:/path to folder. And when you're using Git, that is all you need to do to connect to a remote system, and it just tunnels through SSH, uses SSH behind the scenes, and bang, you're now connected. So once I've done that, I have got code. I can push that code. I can work with that code. Later on, our client got their Active Directory fixed. We could then push our changes back to that Active Directory. So the key concept here is other programs tunnel their stuff through SSH. They don't implement their own network stacks. Next thing I'm going to show you is package management with apt. So if I run, I'm going to show you two commands, and this is all you need to do to update every single package in your system, or every single package that was installed via Package Manager. So the first one, update, well, that connects to the remote repositories and downloads all the metadata. So what it does is it caches all the information about your package system locally, so it's faster to actually work with. And the second one is sudo apt-get upgrade. That's the one that actually does the work and upgrades your packages. Now, why they chose update to update the local cache and upgrade to actually do the upgrade and upgrade the files, I have no idea. Those are just the two words they picked. I'm going to show you another thing now. We're going to use apt to install something. I'm going to use apt to install a text editor. There's a good reason for this, because there's a potential trap waiting for anyone that wants to go near a Unix command line. And in fact, if you're using Git for Windows, enough Linuxy subsystem comes across for you to have this trap as well. So here I am on a Windows command prompt, and I type git commit --amend. And then this happens. You're somewhere that looks a lot like a text editor. It is a text editor, but you start typing away, and nothing happens. Maybe if you start typing away, you might hit the I or O key, and suddenly stuff does happen. You start editing. But then you don't know what to do next. What's happened is you're stuck inside Vim. Because Vim, across the whole Unix world, is pretty much the default text editor. The problem with Vim is it's not intuitive to use. You go in there and you're not in edit mode. You need to know a magic button to press to get into edit mode, and then you need to know the magic button to press to get out of edit mode. You need to know how to save it, you need to know how to exit. And it's doable, but there's a lot to learn. And it's become a thing. In fact, if you Google how to exit, Vim comes up as number 2 after how to exit full screen. So rather than try to learn how to exit Vim, how about we just avoid it completely? So what we're going to do is find something else, sudo apt-get install nano. As soon as you've done that, if you want to run it, that becomes your default text editor. And this editor, it opens up, you start typing, it works, and you've got some helpful stuff at the bottom of all the stuff you probably want to do. You want to exit. If you hit exit, it will ask you to run a save and save it, and it's just interactive and easier to use. Because every piece of configuration inside Linux is a text file, and if you SSH in, you can SSH into any box, you now have all the tools you need to administer any Unix system. You can SSH into it, you can launch a text editor, and you can edit a file. That's all you ever need. So next thing is using a PPA. This is really important if you want to do Microsoft stuff with Linux, because Microsoft have released a lot of stuff recently, and it's not there by default in those package repositories. So what happens if you want to install something from a PPA? You go and find the web page for that thing. Here's the web page for Azure CLI. And when you find, there's a link there, install via apt. So you find the one for the flavor of Linux you've got. And what you get are these chunks of text. And what you do is just copy and paste these chunks of text into your terminal program, and that will do the work for you. If you really want to understand what's going on with those chunks of text, by all means do. But bear in mind, there seems to be an unwritten rule here that every time someone sits down and writes some of these instructions, they do it in an entirely different way for no discernible reason. So here's the instructions for the Azure CLI. And what you're doing is you're downloading something and running a script, and then you're doing something else. And here's the instructions for installing SQL Server, and it's a completely different set of instructions. If you look at Visual Studio Code, it's another completely different set of instructions, which is weird because what's going on in all these three cases is exactly the same thing. What you're doing is you're downloading a key because packages in Linux are signed, so you need to download the sign-in key and accept that key in order to download packages from somewhere else. And then what you're doing is adding a single text file into a configuration folder, which adds that repository to your system. And where that goes is in /etc/apt, which is your package manager, and then sources.d. So if I take a look at my system and I cd, which is change directory, same as Windows, into that folder at etc apt sources.list. Remember, etc is where all configuration is. It's generally /etc/ the name of the program. So you've got Apache installed, it'd be /etc/Apache. Then you look in here, I've got all kinds of different extra packages to install this stuff. Now, the advantage of using PPAs to install software is that if you go back and update everything, that sudo apt-get update, sudo apt-get upgrade, it will upgrade the stuff from the operating system, plus these packages. If these packages have new things, it all gets updated in that one system. So there we've introduced a few key features, a few key things you can use to get working with Linux. Let's now go and start using this Linux with Azure. And the first thing I'm going to show you is the Azure CLI, which I think is awesome. What I want to point out is the commands I'm showing you here, you can, of course, point and click your way through the portal. And I'll show you some portal clicking through stuff later. So anything I show you, you could do it through the portal by clicking or through Azure command line. And you can also do it through PowerShell stuff as well. I like pointing and clicking to kind of the first time I do something. If I want to repeat something or write down the steps, then you may as well write them down in the script so you can just invoke it later and just do the same thing again. So the first thing is AZ login to log into Azure. And it launches a browser window. You click and log in using the standard Windows login stuff. And then you're logged in. Once you're logged in, if you type just AZ and enter, you get a big list of all the commands that are available for you. So the Azure CLI is very interactive. And the great thing about it is this one CLI is the same across many places. This works on Linux, this works on Windows, this works on Mac. It also works from Microsoft Docs. You click a button in Microsoft Docs, it launches a window. You can actually interact directly with your Azure from Microsoft Docs. So what I'm going to do is a few things. The first thing I'm going to do is create a resource group, and that's AZ group create, give it a location, give it a name. And the next thing I need is to find some information. I want to know the right magic string to make my VM size, because I don't want to make big VMs until I need the expenses I'm playing here. So let's make it a small VM. So once I've looked at the size, I can create a VM. So AZ VM create, put it in the resource group, give it an image name. So we're using Ubuntu LTS. That's the image name to install a Ubuntu-based system. Give it a size, put it in Australia East, give it a name. You run that. It says running. A few seconds later, it comes back with some information about your installed VM. The key to point out here is what you're getting back is JSON blocks. You can configure it to give you table information or XML instead, just change a switch. But one thing you're getting back there is a IP address. So what I can do is type SSH Brendan at that IP address, and guess what? I get straight in. The reason I can get straight in is because when I use the Azure CLI to set up my VM, it sets up those keys that I just showed you. There's SSH public and private keys, puts my public key on the server, and I can just get straight in. So that's something the Azure CLI does for you. I mean, it's really fast and smooth to get in there. So it's almost like I showed you this stuff for a reason. One more thing to do once I've got that VM running, and in fact, I could have set this switch when I first set it up, is specify a DNS name. So I'm going to give it the DNS name Northwind Linux VM, and then I hit go, and it gives back me a fully qualified domain name. I now have a system, a remote VM on Linux running at that name, Northwind Linux VM.australiaeast.cloudapp.azure.com. So what can I do with that VM? Well, I can do pretty much anything. It's a fully stacked Linux operating system. So if I log into it, let's install something simple. Let's install a web server. To do that, Nginx is a very good web server. So I can type sudo apt-get install Nginx, and bang, it's now running. It's now installed, sorry. One more command will turn it on, system control start Nginx, and I've got a started web server. One more thing I need to do is just mount the ports. So I open up port 80 and hit go, and now I've got a running web server on that command. So you can see with a few commands, I'm going from installing, install software, open a port, start it, bang, we're running a web server. But that web server's not doing much. I'm a .NET developer. Would I like to deploy a .NET web apps? So let's take a look at how we can go about doing that. Well, first we need to install the Azure CLI. exactly the same as all the other installs. It's via a PPA, so you cut and paste these commands into a terminal, and bang, you've got the .NET runtime installed. Then I'm going to go to my local copy of those files, Northwind Traders. I'm going to run a .NET publish and publish it to an output folder. Pretty standard stuff across all versions of .NET now. Then I need to get those published folders and put it up on the server. So this is where a command that Linux has had for a long, long time. It's called rsync. And you can tell rsync to tunnel through SSH. And what it will do is it will compare the local folder structure and the remote folder structure and do a diff. If it detects a diff, it will transfer the changes. And it will compress those changes. So it will very quickly throw those files up. And so that's why I've always felt, until Octopus Deploy came along, Linux had a much better deploy story than Octopus Deploy then and Windows did. But now that's done, I've taken those published files, and they're bang, they're on the server, ready to go. But I've got a couple more things to do, because what I haven't done is configured that server remotely. It's still got all the same settings from the dev mode. Well, the first thing to do is to set its environment. Now, non-.NET applications are brilliant because they can accept configuration through many ways. They can accept configuration through those app settings files. They can have overrides to those app settings files. But at the very end, you can override any one setting just by specifying what's called an environment variable. And environment variables are great for that last minute, take this on and then add these. The first environment variable we're going to put in is ASP.NET Core environment. And what will happen is when this is set, it will reload the settings from appsettings.json. It'll then look for another file, appsettings.test.json, and put in a whole bunch of settings. But I've also got some more settings I want to specify. I want to specify a connection string. So this is quite long, but I hope you can see at the very top I'm going to export connection strings. Now the connection string isn't just a flat thing right at the top of my configuration file, it's inside a section. There's a connection string sections, and inside that section there's a thing that says Northwind database, and then there's your value. So you can use a number of different delimiter characters to drill from the very top of your configuration right down into that JSON document. But the one I find that works in most places is double underscore. You can sometimes use colons, doesn't work in all places. So the double underscore lets me go from connection strings down to Northwind database, set that value, and now I've specified my connection string. One more thing to set, I want to set up the URLs to bind to. So by default, I think this one had 5001. I'm going to run this on port 80 and 443. So I export those ASP.NET Core URLs is the environment variable to override where Kestrel will bind up to your application. One more thing to cover. Way back in .NET Core 1.0, the recommendation was to not put your .NET Core application directly on the internet because you haven't quite finished locking it down properly yet. In .NET Core 2 and above, they changed that. They say it's totally fine to put your .NET Core application directly on the internet. Now, if you want to put a proxy server in front, you can tweak it to support that, but I'm going to show you how to set it up to run it so that .NET application is the thing on your server that's receiving those requests from the internet. So I thought, right, good to go. Let's go ahead and run that, and I had a bit of a problem. I got this permission denied error. Not great. So what happened there? Well, it turns out that mounting something on port 80 or 443, you need special permissions. So I did a bit of Googling, found this command. I just copy and pasted it from Stack Overflow, basically. Sudo setcap bind service. Let's zoom that out, sorry. Don't expect anyone to remember this command, but just know that something's available to go and turn that off. And with that in place, I can then start that application, .NET, Northwind. So to start a published application in .NET, it's just .NET and the name of the DLL. Off it goes, and bang, I'm running Northwind Traders on Linux, inside the Linux VM. Well, that's great, but the problem with the VM is you have full control of that VM, which is fantastic. I can do whatever I want, I can store whatever software I want, it's mine. But it's a pet. I have to look after that VM. It's my responsibility to keep that thing up to date. It's my responsibility to look after it. And maybe there's an easier way. So VMs are kind of your entry point, but we've got much more options open to us now. We've got things like web apps. So let's take a look at how to go about making an Azure Linux web app. And where I used the CLI before, I'm going to do this via some much easier pointy clicking tools. Now, I don't want you to get the idea that VMs are hard and web apps are easy, because I showed you these Azure CLI for VMs, and I'm showing you the click-through options for Linux web app. Both tools could be used, but I'm going to show you a really easy way to get a web app up and running. If I go into Microsoft Azure, there's a button there, Create a Resource. I then search Azure DevOps, and I find this thing called an Azure DevOps project. Sounds pretty good. I hit Create, and it says, what sort of project would you like to start with? Well, my favorite's .NET. Don't like PHP that much. Putting JavaScript in the server feels kind of wrong to me. .NET. I'm a .NET developer, so I picked that one. And I want to be up to date, so I go with .NET Core. And then once I pick .NET Core, there's all kinds of options. The service fabric clusters, Kubernetes services. But let's try Linux web app. Let's see what we get. So I'll click Linux web app. Some extra things, you give it a name, give it its resource group, put it in Australia East. Top tip then, make sure you go to additional settings in order to set the pricing tier, because if you're playing with it, you want a lower pricing tier. If you're going to use it for production, then work out which is the optimum pricing tier for you. But the pricing tier is tucked away in the additional settings, not there up front. Once you've done that, you click yes and go through, and it says churning away. Your deployment is underway. Takes about, I'd say, 3 or 4 minutes, and then finally it says done and brings you to this page. So what have you got? You've got loads of stuff. You've got this home page inside portal.azure.com that tells you a bit about what's going on. If you click from there into, say, project homepage or repositories, you've got a dev.azure.com Azure DevOps project for your site. And that's got a task board and all that kind of stuff. It's also got a source control in Git. So it's got a Git repository with a sample application deployed in there. You also get a build pipeline that will build that application, and a release pipeline that will release that application on demand. And finally, you get a running Linux web app sat there on the system and a sample app deployed to a Linux web app. Fantastic. Everything done. Click 3 or 4 things, and I've got everything good to go. And then all I need to do to make my app is just go to that repository, replace the code that's there with my code, and away you go. So I thought, this is fantastic. I've got this Linux app deployed. Let's find out a bit about the Linux side. I like the Linux stuff. So I had a look at the Linux web app here. And I looked down and I saw this, SSH. Well, I know what that is. Let's take a look at what's going on there. So I logged in, and now inside the browser, I have got a little shell that I can use to poke around inside my Linux install. Great, I thought. Let's have a look around. And I poked around, and I found it was a bit odd. It wasn't exactly like a Linux install I was used to. I thought, well, maybe I can come in here and install stuff. Maybe I can come in here and what can I do with it? And I quickly realized that, well, the first thing I looked at was to see that it is a Ubuntu-based system. But things were a bit weird. I tried playing and installing stuff, and stuff would disappear. And I realized that are we not inside a full system? Are we inside a container? So I Googled, how do you find out if you're in a container? And this guy, Thomas, comes back and says, we can't tell you whether you're living in the matrix, but I can tell you whether or not you're living inside a container. And to do it, you don't expect anyone to remember this, but if you go and look at something under proc here, and if you see the word Docker after running this command, that means you're inside a Docker container. So that's great. We've actually created a Dockerized, containerized application just through that pointing and clicking. What was a bit weird is it didn't tell me it was creating containers. Like, containers are cool, but it didn't tell me I was doing containers when I clicked through. When I clicked through again and found out a bit more, containers are mentioned there actually. And what you get are these are the things that you can choose when you're building a Linux web app. And so what these different things are different containers that it will start to run your Linux web app in. So what you can do with that SSH command is you can log in, look at logs, see processes running, look at memory. What you shouldn't do is use it to install new dependencies in there, because that will get blown away if the app restarts. So how do I take control and put more dependencies? How do I take control on that application and actually put more stuff in there? Maybe I'm doing a PDF generator that has some dependencies on some more windowy type stuff. I can't do that very well with this fixed container. So what I need to do is actually start making my own container. And that's where Azure Web Apps for Container comes in. So an Azure Linux web app will deploy a container for Linux containing your app. Azure Web Apps for Containers lets you control that container. So let's start by taking a look at containers, what they are, and how to go about building them. Well, unlike a VM, containers kind of start at the opposite end, at the smallest part of the system, because a VM, a virtual machine, starts by virtualizing all the hardware of a machine and then booting a complete system on top. But containers are more about creating a sandbox in which to run applications. It keeps as much of the system existing there and creates a sandbox. So the very first concept of this kind of secure sandbox we had was in the 1970s when Unix operating systems got this command called chroot, change root. And what this did was say, for this running process, change where it thinks the root of my the root slash, like the root location of all those path systems are. So if I think root is just this subfolder, I can't navigate above that and go somewhere I'm not supposed to. So those ideas changed quite a bit over time. They built on that, and that's kind of the technology with some other user-based stuff that gave us this super cheap, $10 a month hosting in the 90s. All these shared web hosting that had cheap PHP, cheap MySQL hosting. You'd have a login with SSH that would put you into a system where you can only navigate to your files. You'd have FTP to upload your stuff. And this is why PHP became hugely popular, why we've got Facebook, why we've got WordPress, and so on. So over time, they built on these ideas of chroot and added more stuff to make jails. BSD had this concept of jails. And at some point, we had this thing called LXC coming on. To say at some point, it was around about 2008. So at this point, we're taking this idea of this virtual drive root system that you can't move out and actually virtualizing a whole lot more. So putting a whole container with much more control over various process isolation, networking isolation, file system isolation. And LXC then became the engine that drove the first version of Docker. So Docker doesn't use LHC anymore, but the first version of Docker did use LHC. So now Docker has taken this idea of this containerized sandbox thing and builds a full sandbox, the full kind of system, and adds the concept of images. So you can take this sandboxed container system, turn it into an image, and deploy it somewhere else. So how do we go about building a containerized system? Well, let's start by running some stuff in Docker. Linux and Docker are just amazing together because Docker was first made for Linux. Like the first thing was Linux. It's a Linux thing. You can do Windows containers, but it really is a first-class Linux citizen. So the first thing I'm going to do is take a Docker install and run something. What I'm going to run is something called Hello World. So Docker run Hello World. When you say Docker run, the name you give it next is a name of an image. So what this does, this runs something, it downloads an image and says hello from Docker. So what happened here is it started the Docker process, downloaded an image, booted that image, connected that image up to my console, streamed out the results of my console, and then finished and closed down the container. So this is your kind of most basic thing you can do. It's just exists to say, I've got Docker installed and Docker is working. So let's do a bit more. Well, the next thing we can do is start searching for images. There is a website called hub.docker.com, and that has a huge repository of various images I can do to run containerized stuff inside my local system. So I go browsing around on hub.docker.com and I find some images. So here's another image. It's called Ubuntu, and this one will run a pretty full Ubuntu install inside that image. And that runs and puts that install in place, and now I'm logged in via secure shell into that Docker instance. Now this looks a lot like what you saw when you'd SSH that button into your Linux web app. Okay, so this is running a operating system locally. Let's run something more useful. Let's go to .NET Core samples. That's under hub.docker.com. Let's find one. They've got a sample ASP net app. So let's go and run that. So I'm going to go docker run -IT, which makes it interactive. -P mounts up some ports. So it's going to take port 80 on the Docker containerized application, mounted to 8080 on my system, and then here is the magic string for the image name we're going to run. So if we run that, it basically, inside that Dockerized container, is now running the ASP.NET Core sample app. And if I browse to port 8080, there is that sample app running. So Docker's great because I can take applications and all the dependencies, drop them into this container, run them locally, and then they just work. If it works on one instance of Docker, it'll work on another instance of Docker. All you've got to do is just mount up the URLs. So I quite often use Docker to run SQL Server. Who here has broken their SQL Server instance and had to mess around? Most people. Yeah. So I've put it in a container. You can get another version of SQL Server without having to break your previous system SQL Server. Quite often, if you're doing more advanced things like report server, you need a slightly different version of SQL Store installed. So just grab a container, put that in, and don't have to mess around with multiple instances on your box. Okay, so we've played with Docker. We've downloaded images. We've made those images run locally. But what if I want to make my own image? This is the really key thing. I want to make my own containerized, Dockerized app and deploy it somewhere. Well, to make your own image, you have to create something called a Docker file. And it's a big text file with a series of instructions. And what happens with the Docker file is you start with this from command. And the from command says the image you're going to start with. So most images start with someone else's image and then add stuff to it. Well, before we go any further, let's see what's going on with that image. Because the key thing with Docker is each of the images you're using are there on open source. They're available. You can dig down. So let's go and find that mcr.microsoft.com image. If we take a look at that, we can find it on GitHub. And we can see, OK, that starts with another image called buster-scm and installs all kinds of .NET stuff. So it installs all the tooling we need. If we go another step back, we can see a whole series of images based on images, based on images, until we get right back to something called Debian Buster. Remember, that was the name of the current release of Debian. Until we get to one that doesn't say from, it says from scratch and copies a bunch of files in place. So the key thing with Docker is images get built from other images. And the other thing is, as you run through commands to build your image, the output of every single command is another image that can be cached. So when you work that way, so let's step forward now. So we started with that Microsoft SDK image. And what we're going to do is install a bunch of stuff into that SDK image. The SDK image has all the tools we need to build .NET, but Northwind Traders also has the Angular CLI. So it has Angular installed. So if we want to build it, we need to install the Angular CLI. So we're going to use a PPA, and basically we're copying the instructions from how to install Node, and we're dropping them into this Docker build. And we're going to install Node.js. Once we've got Node.js, we're going to install the Angular CLI. The next thing we're going to do is, and this is a kind of tip for building .NET stuff in for a Docker image. What we want to do is actually run .NET Restore first as a first step, and then run .NET Publish. Now, if you run .NET Publish, it will, yes, do a restore and then a build, but then that's just one step. If you do the restore separately, the output of the restore is a new image, and you can then cache that save point in your path. So you're not going to, as you then move that image around, it's not going to keep re-uploading the results of the .NET Restore, so all your dependencies. So you do a .NET Restore first as a separate command, and that then caches the results of .NET Restore, and it won't completely rebuild that every single time. Then you run a build and a publish. So what we've got now is this image that's based on the .NET Core SDK, and we've used it to build our application. And we've run the .NET published and put those files in a folder. We don't want to push that to production, because that particular image has all our SDK tools in there. It's got the full Microsoft SDK. It's got the Angular CLI installed. We don't need that at runtime. All we need at runtime is an ASP.NET Core runtime and our compiled app. So what we do is we take another image called ASP.NET, and that image is much smaller. So where the build image has all the tools we need for building, the runtime image is much smaller, optimized for runtime, and we then take our application and copy it from our build image up to our runtime image. And the runtime image is what we use to ship up to the servers. So another key point here is, who's heard of the works on my machine problem? Most people. What about builds on my machine? Every bit as important is How do I hacking around with your build server to make sure your build server has the dependencies it needs to work as well? Well, when you're using Docker, you create a Docker image to build, and you create a Docker image to run. And so the same, if you can make it build on your machine with that Docker image, when that thing gets run somewhere else, it'll still work. So not only do you fix the works on my machine by using Docker, you fix the builds on my machine by using Docker, because you actually use Docker to build, then you use Docker to run. And finally, at the very end, we feed in the command to make that application run, go .NET and the name of the DLL. So let's go ahead and run this. And this is why I really like Docker, because now I've made a Docker build file. I can run that build locally. So say Docker build dot to say the current folder, -t to give it a tag name. And it runs, downloads all those different images up the chain, all the way up to that source image to build the system. And then it runs Docker build, builds it up, and we've now got a Docker image installed on our local system. Now, if I want to run that Docker container on my local system, I've got to do one small thing, and that's because this application has ASP.NET Core Identity installed, and to run it, it needs some certificates. So what I'm doing here is I'm running .NET dev certs HTTPS, and actually generating a local dev certificate into a folder, my home folder /ASP.NET. So what I've done is I've created a copy of the dev certificates in my local machine. Then when I run it, this is getting a bit bigger, but what I need to do is basically when I start that container, I need to mount an extra tiny bit of my local folder containing those dev certificates into that container, and then tell Kestrel to look in this location to fetch those certs. So let me say that again. I'm feeding in all kinds of settings. I'm setting in the connection string, I'm setting the environment, but I also need to tell it where to find my certificates. The certificates are on my local machine, so I need to mount that folder on my local machine to go and grab those certs. You don't always need to do this, but this is what you need to do to mount this application on your local machine. This is best practice. What I could, of course, do is generate those certificates and put them inside the container. But then that container contains your certificates, which is far less secure. Much better to feed those certificates in at runtime. When you go moving to Azure, you've got all kinds of tools to manage that. So you can use the, I'll show you some of that later, but there's Azure Key Vault. It's perfect for managing those certificates. But the best practice is do not put certificates inside your container. Get the whatever system you're deploying to push those certificates in later. So that all set up, I can type run, and it starts up, and bang, I'm running that same application now inside a container on my local machine. Now I've got a containerized application, I can start looking at how to ship that across to Azure. So how do I move that onto Azure? Well, we've introduced Docker Hub. Docker Hub is a container repository where you can put your images and then other people can download those images. But I don't want to share my image. My image is my image. I could pay for a premium version of Docker Hub that gives me a private image repository. But there's also something called the Azure Container Registry. So the Azure Container Registry exists to hold Docker images. So go and create one of those. And I fill in some details, say which resource group it's in, give it the basic SKU. Also, if you want the Azure Container thing to work with Docker, if you enable an admin user, you get a username and password you can use to send it up. Otherwise, you can use the Azure CLI to send stuff up. But if you want to use just Docker commands to send that image up, you enable the admin user. The other thing I love about this local build is it's very simple. Here's an example of taking that Dockerized build and making it happen from an Azure DevOps pipeline. So basically, you just click through and pick Docker task in your Azure DevOps pipeline, and it builds you this chunk of YAML. It means you don't have to touch the YAML. You just feed in the details. Here's the image. Here's the path to the image in my source code. And here's the details of the ACR repository to send it up to. It'll authenticate itself against there, generate this YAML file, and you don't have to touch the YAML because I hate YAML. Once you've done that, you have placed your stuff up in that repository. So this is the what that repository looks like, that container registry, and that is it. That is your image uploaded into that container registry. Actually, no, that's created an empty container registry. You now need to put in the commands to upload that image from your local machine up to that container registry. So to do that, the best way is to use the Azure CLI, because then that does the authentication for you. So AZ ACL login, give it a name. Then you do Docker tag, and you tag it with the full URL of that remote repository. So take the local name of your image, give it the remote name of your image, and then you go Docker push, and it pushes that image up. So now anytime that image gets pushed, it'll update that container on the remote side. Then finally, and there you can see that image is now uploaded into our container repository. And finally from there, we can go create a web app for containers. So we go into Azure, go web app for containers, give it some details, give it the login or the location to our image repository. In it goes, review and create. That then runs away. And what we can do now is go ahead and set up the configuration. So we've got the image, but once again, if we want to configure that running application, the best way to do so is via environment variables. So we create an environment variable that says ASP.NET Core environment. We create an environment variable that says where to find what URLs to run, and we create an environment variable that says here is our connection string. So one thing I'm doing here is when I'm saying what URLs to respond to, I'm only providing port 80. Why am I doing that? Well, when you deploy a Linux web app to web apps for containers, it actually sets up its own proxy server that terminates the HTTPS connection. So by default, you deploy to web apps for containers. The termination of the SSL traffic is done for you. So that's doing the HTTPS stuff. It sets that up, it puts in the certificate for you, and that's all done. It will then forward those requests through as port 80. So you only need to listen to port 80. But if you're using Identity Server needs to know that it's behind a proxy because it wants to redirect you out. In fact, there's a setting inside your application that says app.require HTTPS. If that's turned on, it'll receive a request to HTTP 80 and say, oh, that can't be right, I need to redirect. So what you need to do is come into your services here, and there's an extra bit of configuration. First one is configure forwarded header options, and then later down in the top of your configure section, it's app.use forwarded headers. Those two magic incantations say if I receive a request from a proxy server, and that proxy server said, yep, I've got this forwarded from a secure thing down through to a non-secure thing, it'll accept that header and say, okay, this was a secure connection, and won't redirect you to HTTPS. And finally, there we are with Northwind Traders, hosted in a web app for containers, running securely. You can see it's not running dev certs anymore. It's using Azure's own certs for it, and bang, that's it running. I would make a terrible fairy tale author because I started with the Goldilocks option. I've told you web app for containers, the one in the middle, which I think for most workloads is the right one to use. There are two other ways of putting a containerized application into Azure. The first one at the top is container instances. They are incredibly simple. You say, here is a container, here are some ports to mount up, and away you go, just mount that container. I find that's good for really simple workloads. I've been using it to generate load traffic if I'm doing some load testing. Web app for containers, for me, are much better for web apps because they have elastic scale. You can set them up to actually scale out to multiple servers and scale down. So you've got all those systems you get with an app service, you get web app for containers. The next one is a much bigger option. That's Kubernetes. Kubernetes is a big, complicated system with a big, complicated learning curve. If you have a very complicated requirement, you should consider Kubernetes. What it does is it allows you to, it's an orchestration service, allowing you to make lots of containers and put them out and spread them out into lots of systems. It will configure networking between those containers. It's fault tolerance, all kinds of, you can do A/B testing with the configuration there. So that is kind of your sort of most complicated and best option for a real complicated workload. But for most workloads in the middle, Web app containers is probably your Goldilocks happy medium. You've got some scalability, you've got the ability to scale out, but you don't have to do the whole complexity of learning how to use Kubernetes. Okay, so that's all the kind of Linux web apps. So we're going to look at a couple more things. I know we're short on time, but these are quite quick. So what we've looked at is taking entire applications and putting them up into the cloud. But that's not the only thing you can do. There's also this new serverless thing. So for certain small workloads with incredibly good scale, functions are a great way to go. And you've got the option to do Linux functions. So let's take a look at that. So the first thing to do to write Linux functions is to install some tooling. So we're going to install the Azure Functions core tools, and you can get these same tools for Windows as well. And away they go. And once you've installed that, you get this command called func. And if you just type func, it'll tell you all about the different things you can make. If I want to make a new project for an Azure-based Linux function, it's func init and then a name. And I've created a name called sometimes win, because I'm going to make a little gambling app where you sometimes win, sometimes lose. So you say func init sometimes win, and it asks you to select a worker runtime. And you can pick .NET, Node, Python, or PowerShell. Well, I'm a .NET developer, I'll pick .NET. Who can make a guess at what the implication of picking one of those things does? What do you get when you pick one of those four options? You get a container. So when you pick .NET, you'll get a .NET container, a container with .NET installed. If you pick Node, you'll get a container with Node installed. But you also get a template to work with as well. Yeah, so actually that was partly true, but that wasn't the point I was trying to make. Yeah, there's two truths. So you choose option 1, and that will then create you a local project. If I look at that project, it's an empty project. I've got a CS proj file. I've got a couple of configuration JSON files, so I'm ready to go. I want to create a function, so the command is func new. Then ask me what sort of function I want to create. And it's got all these different templates, Q triggers, HTTP triggers. These are all different trigger types that Azure can use to say run my function. Well, the easiest one to work with is HTTP trigger. So I'll pick that one. It gets created, and then take a look. And I'm going to make some code. I'm going to make some code that runs basically a coin flip with a random number and says sometimes it will say you have won fantastic prizes, and sometimes it will say bad luck, you did not win. Pretty simple application. Once I've done that, I want to check that out locally. It's func start -- build. It will go ahead and build that application, run that application locally. And in the green there it says, I've just started that local application on localhost 7071. So I plug that in, and you give it a go, and it's a stupid application. Look at it, I never win anything. Oh no, it's a brilliant application, it's amazing. How good is that? All right, so we've created an application. We want to put it up on Linux, up on Azure, sorry. We've got it running locally. How do we go and put it on Azure? Let's go and create a resource group for it to go into. So bang, up it goes into resource group. Sorry, that's creating the resource group. Then the next command, functions need a storage account to work. That's where they store stuff when they're not running, or they just need a storage account. So we create a storage account, AZ storage account create, a whole bunch of different settings. Up that goes. So we've created a resource group, we've created a storage account. The next one is AZ function app. So AZ function app create, we give it a name, we tell what resource group it belongs to, tell the consumption pan location, OS type, the storage account, and the runtime. And away that goes. And that churns away, gives us all kinds of information until eventually it's created. And finally, one more thing to do. Now we've got that place to install to. We say func Azure function app publish and give it the names. And that runs away and starts up the system and gives us this green URL. We plug that green URL into the browser, and once again, our app is working. So those are the steps to get a function app in place. And once again, as I said before, what you're building here are containers. If you want to take control of those, if you want to make a custom container, yes, you can. Just go to, I haven't got the demo for this, but if you go to docs.microsoft.com, there are instructions here on how to create a function on Linux using a custom image. So if you've got a certain thing you want to do, such as generate a PDF, you need some libraries that aren't there in the default image, then go ahead and build your own custom image with those libraries. The main difference is when you start the function, you go func init my project and go -- docker. And when you do that, it puts a Docker file in your application. And then if you browse onto hub.docker.com, all the images that are available to you by default to work with are there on Docker Hub. So fully open source. You can see the base one, a .NET one, a Node. So if I wanted to make a .NET stuff and add my own dependencies to it, I would start with a .NET image, install extra software, create that image in the Docker file, and bang, you can then install that as an extra image. Yes?
Do you need to create a new image if you want to just add NuGet dependencies?
I would say yes. If you do want to add NuGet dependencies, yeah, the question was, do you want to make a new image to install NuGet dependencies? And yeah, I would, because it's, depends actually. Yeah, depends on your application. Because if it's actually part of your application, then the standard ones for .NET Core will run the application you give it, and actually the NuGet dependencies get compiled into your application. So NuGet dependencies, I'll change my mind there and say NuGet dependencies I wouldn't, because actually the thing you've got is able to run those NuGet dependencies. It's NuGet dependencies that ship with another dependency. I need something else installed. So external libraries, yeah. Okay, so we've looked at a whole bunch of things here. We've looked at VMs for Azure CLI, Linux web apps for containers, and even Linux functions. And what's becoming clear is containers are involved pretty much everywhere except VMs. So containers are the story for so much stuff. And on the docs, there's some great stuff that uses containers. But there's some places that containers are no good. And the place that containers are no good is in IoT, because containers are still too big. And that's where Azure Sphere comes in. So Azure Sphere is in preview right now. It's a comprehensive IoT security solution. Now, Microsoft have done some stuff with IoT before. They have made a much smaller version of Windows, so small it can fit inside a Raspberry Pi. Pretty good. But when you're talking IoT, though, a Raspberry Pi isn't really a thing. A Raspberry Pi is just a surprisingly small desktop computer. It's not a tiny Internet of Things. The whole concept of the Internet of Things of tiny things, of which there are many to run. A Raspberry Pi is huge. And I'll show you just how small IoT things go fairly soon. So what is Azure Sphere? Azure Sphere is a Linux-based OS from Microsoft. Let me say that again. Azure Sphere is a Linux operating system made by Microsoft. Hell has truly frozen over. And it's for IoT. So being for IoT, it's very, very small. I'll show you just how small in a minute. The main thing they've added from any other, there are plenty of small Linuxes out there, but the key point of Sphere OS is security. It has secure boot systems in there, so you can't just accept any old applications. So it's locked down and key signed on the hardware itself for specific versions to come from Sphere OS. The reason they do that is then that then allows over-the-air updates. You've got these things out there in the world, and you can send security patches to them over the air, so just over Wi-Fi. And it also has great error reporting features, and all the traffic goes straight up to Azure, so it's really good communication between Azure and your things. So how would you go about using Sphere OS? We need to get one of these things, a MT360 development board. And this is a tiny, it's 8mm long. It's basically a chip, and this is the dev version. It's a dev version because it's got all these pins on it that you can play with. Obviously, when you then go to make 1 million of these, and you want to then use them for an application, you'd probably just keep the chip bit in the middle and put it on your own PCB board. So here is the dev kit, and once you've got the dev kit, you can start working with it. So let's have a look at this dev device. It is, that's way out of order. It is a 500 megahertz ARM-based processor, nice and small. It has 4 megabytes of RAM. That's it. So they've got an operating system that runs in 4 megabytes of RAM and can talk to the internet and send data up. So this is not a device that's going to do image processing on the fly. This is not a device that's going to make decisions. This device is there to collect whatever telemetry is up there and send that telemetry straight up. So it's got some dedicated I/O sub-processors, really good at I/O, really terrible at keeping the data. It's just to stream it out. And it's small. It's 85 by 50 millimeters, and that's for the dev kit board. Real boards, once they're made, were even tinier. So the key point with this thing here is it's something really tiny for actual dedicated Internet of Things applications. We're no longer trying to fit big chunky Windows applications into an IoT device. We've got a tiny, tiny IoT device that's about as small as I've ever seen Linux get, dedicated for IoT with dedicated security systems on top to receive signed over-the-air updates. So that's pretty much all I wanted to cover today. Just wanted to make a mention of Azure Sphere and see how that fit in. We talked about package management, and basically package management is the one thing to learn to work with Linux, because that's how you install software. And then if you want to make a custom container or want to change the install of a Linux VM, that's the thing to use. You use the package management tools to get your software in, and sometimes you have to go to an external repository to go and fetch the information, and that's what the PPAs are. So we looked at package management, a few shell commands, and SSH is a really important one to learn. Then we looked at managing VMs, Linux web apps, and Linux web apps are ones where you get a fixed predefined container. Azure Web Apps for Containers, where you can build your own, finding Linux functions, and Azure Sphere. And so thank you all so much for staying till the very end of the conference. I've been Brendan from SSW, and if you've been doing the SSW app, please get that code. Thank you.